Have you ever wondered if our generation could ever cure cancer, blindness, or even give a paraplegic the chance to walk again? Well, stem cell research could lead to the answer to these questions. To introduce stem cells, they're undifferentiated cells that can give rise to several different cell types. For example, a stem cell could give rise to a liver cell, a heart cell, a lung cell, or even a neuron. These stem cells come from various parts of the body, but they're only categorized into two different types. They're categorized into adult stem cells and embryonic stem cells. The adult stem cells, they're a little more specific in the cells that they can give rise to. For example, they only give rise to like native cells or cells that are close to them. Like a heart stem cell is only going to give rise to heart cells. A liver stem cell is only going to give rise to a liver cell. Now, the adult stem cells, they may be able to be coaxed into other cell types, but it's not done very easily, and we'll talk a little bit about that later. And the embryonic stem cells, they're the ones that are more important for the research because they're pluripotent, meaning they can give rise to many different cell types like I was explaining earlier. Liver cells, lung cells, heart cells, they can be any of those, depending on which one the researcher wants them to be. Cell research today has generated the new knowledge about the intricate cell system that's crucial for understanding the cure to diseases and cancers. So today I'll be addressing the benefits and uses of stem cell research and arguing for the acceptance of this medical research along with its funding. To begin, I'd like to give you some of the benefits of stem cell research today and some that will lie in the future. Today we use stem cell research for cancer patients, mainly going through radiation, or blood cancer patients like leukemia patients. The way they use these stem cells is through bone marrow transplants. The bone marrow holds blood stem cells, and when they transplant the bone marrow from a healthy patient into the cancer patient, the blood stem cells, they almost automatically begin generating new blood cells, white and red ones. The white ones are important for the immune system. That's why cancer patients get sick really easily, and they stay sick and, because all their white blood cells are dead and their blood stem cells are dead, so they can't generate any new ones, so their immune system is suppressed. And the red blood cells that are also created are good for carrying oxygen for respiration of the body. With stem cell research, theoretically, we could cure almost all diseases. They could be used to grow back neurons, like I was saying earlier. They could be used to treat spinal cord injuries, Alzheimer's disease, or another neurological disease. They could also be used to grow organs ready for transplantation, and there's many more things that stem cells could be used for. The next point that I want to talk about is probably one of the most interesting things about stem cell research, at least for me. If the researchers could figure out how the embryonic stem cells develop into mature cells, and they could figure out what is signaling them to grow into the adult cells, we could figure out that signal and then use it on ourselves for our own cells to repair themselves, so we would never even have to transplant these stem cells. With stem cells, we could theoretically grow any type of cells, like I was saying earlier, so we could test new drugs on specific tissues without ever having to test them out on humans first. For example, some of the research that has been done recently, in 2007 at the University of Kyoto in Japan, some researchers figured out that they could coax just regular human somatic cells to transform into beating heart cells. They were able to do this because they figured out how to induce pluripotency, meaning that they just made a normal somatic cell pluripotent again, meaning that now that cell can be transformed into any cell type that they want, and they were able to make them into beating heart cells. And then in 2016, the Scottish National Blood Transfusion Service, they upped their production of red blood cells with blood stem cells, and now they have virtually a limitless supply of clean blood ready for transfusion. And the last thing that I'd like to hit on is the ethical dilemma of stem cell research. As of now, most people are familiar with the medical benefits of stem cell research, at least the benefits that they can deliver, and they're less familiar with the ethical dilemma along with the research. Most of the ethics debate is along with the morality of destroying human embryos for the benefits of others. But I'd like to argue and say that the pluripotent cells that the researchers use are collected from only 5 to 7 day old blastocytes that can be even grown in the lab in vitro. And the researchers, all they need is the cells on the inside wall of these blastocytes. Those are the pluripotent cells. And as the former Utah State Senator Orrin G. Hatch said, he said, "I believe human life begins in the womb, not a petri dish or refrigerator. To me, the morality of the situation dictates that these embryos, which are routinely discarded, be used to improve and save lives. The tragedy would be not using these embryos to save lives when the alternative is that they would be discarded." And to explain what Orrin G. Hatch is saying here is that these 5-day-old embryos are they're only 5 days old. They're made in the lab, and the ethical dilemma around them is destroying the embryo. And yes, we have to destroy the embryo to collect the pluripotent cells on the inside of these blastocytes. And he's saying that this would be beneficial for the overall public health, that it's not ethically wrong because it's not human life, because it's not in the womb. And it's not even technically an embryo yet because it's only 5 days old. It's just a cell mass. And as of 2019, the U.S. stands around 64%, saying that it's morally acceptable to do this stem cell research, with 31% saying that it's not acceptable, and 5% undecided or they don't care. And to add one last thing, with the new breakthroughs in stem cell biology that I was saying earlier, that they could induce pluripotency, that could probably get around the ethical dilemma, because now they no longer have to have these embryonic stem cells that they collect from blastocytes, because now they can just induce regular somatic cells to act like embryonic stem cells. And to conclude, stem cell research is very important. As I've been saying this whole time, it needs to be increased in the United States to gain more understanding on some very serious diseases along with their cures. With a better understanding of stem cell research, our health knowledge will grow vastly, and the stem cells may have many uses that are undiscovered, of course, and there's many that we have already discovered.